Welcome to Algebra 1 with Miss Betsy. Today we are continuing our discussion of inequalities by learning about disjunctions. We're going to learn what they are, how we solve them, how we graph them. For our text, we are using Algebra 1 for Christian Schools. It's published by Bob Jones University Press. This video is keyed to the second edition. There are differences in sequencing with the third edition. Still covers a lot of the same material, and you can definitely gain value from this video regardless of what text you're using. So let's pray, see what our lame joke is, and get started with this. Father, thank you for another day of life that you've given to us. Thank you for a beautiful, pleasant fall weekend. I ask, Lord, that you would give us ears to hear you today. Father, that we would be sensitive to your direction in our lives, and that you would give us the willingness to study and to learn the things that you place before us, whether it's algebra or Spanish or just something about everyday life. Help us to honor and glorify you in all that we do, and I pray in Jesus' name, amen. Okay, we have finished talking. In our last video we were discussing conjunctions. And conjunctions are mathematical sentences where you have two conditions going on at the same time, and you have to fulfill both of those conditions in order to have a true statement. For example, if your dad says, okay, Bob, you want to use the car tonight? Well, then I need you first to mow the yard, and then I need you to wash the car. So what is Dad saying? Well, you can either wash the car or you can mow the lawn if you want to go out. No, Dad says you have to fulfill both of those conditions in order for you to gain the privilege of taking the car for the evening. That's what a conjunction is. What we're talking about today is disjunctions. I've copied the definition of disjunction from our book, and it says that a disjunction is a compound sentence consisting of mathematical statements connected by or, which means union, which is symbolized by that the looking symbol. And the key thing here with a disjunction is the word or. Conjunctions have and, disjunctions are or. And when you have or in a statement, it means you don't have to fulfill both conditions or all three conditions. You have to simply fulfill one of the conditions, and then everything is fine. If I tell my kids, okay, today I need you to do some work for me, you may either work on cleaning out the garage or you may work outside weed eating. And do they have to do both of those things? No. They can either work on the garage or they can do weed eating. Would I be blessed if they did that? Both of them? Well, sure, but that's not what the conditions that I'd set before them. As long as they choose one of those two chores to complete, they've met my requirements. And that's what we're going to be talking about today with disjunctions in a mathematical sense, where you have two separate statements, and as long as one of those statements is true, you've solved the inequality. People tend to have difficulty with conjunctions and with disjunctions, and we confuse these. So we have, maybe sometimes it helps to do things alphabetically. Like I'll say, when you're ordering your variables, do them alphabetically. Well, here's some alphabetical ideas that might help you. Let's look at conjunctions. And then we're going to contrast those with disjunctions. And hopefully we're going to have some better markers going on here. C comes before D in the alphabet. Conjunction, disjunction. Intersection, and union. And or. conjunction, intersection, and this is conjunctions are represented by the intersection or by the overlap of two conditions. So if we have a green circle and we have a blue circle, the only solution to these conjunctions is this area of overlap, because we have blue here and we also have green. So this is what the conjunction is. It's the intersection. This Venn diagram here shows the intersection of two sets, and the "and" means that our shaded area here has to be both a part of the green circle and a part of the blue circle. Now over here, when we're talking about disjunctions, D is after C, U is after I, O is after and these all go together. A disjunction, we're going to draw a Venn diagram here. Again, we have the green circle and we have the blue circle. Union, you remember from when we were studying sets, it takes everything that there is and pulls all of that in as a part of the group. So the union here would be the green circle, everything that's contained in the green circle. It would be also everything that is contained in the blue circle. So the union puts all of the elements together, and it says as long as it's either a part of the green circle or it's a part of the blue circle, it's part of the solution. Now, is there a piece of that in this particular case here that I drew where it's a part of the solution is part of both the green and blue circles? Yes, but that's not necessarily true. So disjunctions, we're talking about unions. We're always going to have the word or with them. You fulfill one condition or the other. Conjunctions, we're always talking about intersection. We're talking about that area of overlap. And we're going to see that we solve these graphically in a very similar manner to how we solved disjunctions. Matter of fact, we're going to take exactly the same approach where we draw the number line and we shade two different conditions. We sketch in two different conditions above the number line, but it's how we interpret those conditions that we sketch in that helps us to understand the solution to our problem. Example number 1 on page 197 says this. It says x less than 4 or x greater than, or x less than or equal to 2. So we have x less than 4 or x greater than or equal to 2. So let's go ahead and sketch our number line first. We know that we're going to be having points of 2 and 4 on here, so let's just do this real fast sketch right here. And I'm going to do -4, -2, 0, 2, 4. Do you have to have those exact points on here? No, it's just convenient with the 2 and the 4 that we have, and it just has that symmetry that I like. First, we're going to look at this at our black graph, and we're going to, at our black inequality, and we're going to sketch that graph above the number line. What does it mean if we say that x is less than 4? Well, it tells us that 4 is not a part of the solution, so we have an open circle. But everything smaller than 4, or to the left on the number line, is a part of the solution. So there we have sketched our graph of x is less than 4. Our second condition tells us that x can be less than or equal to 2. And because it can be equal to 2, we have a solid circle. And again, anything that is less than or to the left. So we now have graphed two inequalities here. Now, if we were doing conjunctions in our last section, we were looking for the area of overlap. You remember that? But we're not looking for the area of overlap. We're looking for, perhaps you could say, an area of inclusion. We're going to include every possible solution here of our graph. And, well, I'm trying to write inclusion with a D, and that doesn't work. Inclusion. So what's the biggest part? We want to, it doesn't have, the solution doesn't have to be found both areas. So what is the union, or how do we express every part here on the number line that's been shaded? Well, it's this one right here, isn't it? X less than 4. So our solution is x is less than 4. You say, yeah, but that's exactly what it says there. You didn't combine anything together. That's true, because all we are looking, and that won't even go in there, it's going to chew that up. All we're looking for here, only requirement is that at least one of these conditions be met. Or you have the biggest possible graph that you have. So we have x less than 4. Let's go ahead and look at page 198 and see what our second example says. We have x is less than -4, or x is greater than a -1. So let's see what we have now. X is less than a -4, was it a -1? Or x is greater than a -1. What are we going to do? We start off the same as if we were graphing conjunctions. We do that by drawing our number line. I'm going to have -4, -3, -2, -1, 0, and 4. That's all I'm going to identify on this graph for now. We're going to graph both of these inequalities separately above the same number line. X less than 4, we have an open circle, and we shade everything to the right. -4, well, I said x less than 4. It's x less than a -4. We have an open circle because -4 is not a part of the solution, but everything smaller than it is a part of the solution. And then we have x greater than a -1. Here we have a -1 is not a part of the solution, but everything to the right of that is. So here is our graphical representation of our solution. We have graphed each inequality separately on the same number line. Now, how are we going to solve this? What are we looking for? This is a disjunction. The fact that we have or here tells us that we are talking about the union of these two different solution sets. And as long as one of these conditions is met, it's true. So let's pick some test points here. Is -2 a part of our solution? No, it's not shaded at all. That you don't have the graph of either of those inequalities covering this area. So -2's not a part of the solution, nor is any of this area here because it's all blank. But what if we said x were equal to 0? Is 0 a part of the solution? Yes, 0 is a part of the solution for our green inequality. Is 0 a part of our solution over here for the blue inequality? No, it's not. But does that matter? It doesn't matter, because with a disjunction, your solution only has to make a true inequality for one of them. So our green area here is part of our solution. Now let's take a test point over here. What if we tried -5? Is -5 a part of the solution? Is it true that -5 is less than -4? Yes, that's true. So -5 fulfills this inequality. Now, is negative 5 greater than a negative 1? Duh. No, of course it's not. But it doesn't matter because we only have to have one of these conditions met. So what is the union? The union is written no differently from what our original problem says. What's our solution? Our solution is either x is less than negative 4 or x is greater than a negative 1. And that is the solution. This is the disjunction. Only one condition has to be met. Okay? Everybody make sure that you understand this because I'm getting ready to change this problem on you back to a conjunction. So I'm going to change that from an or to an and let's see what happens here. What do we know about a conjunction? Conjunctions are intersections. Conjunctions are ands, which are intersections, which means that your solution must satisfy both of these inequalities in order for it to be true. It's the area of overlap. You got to do them both. This area right here where we only have the blue marker doesn't meet the conditions. Area here where we only have the black doesn't work. The only area of solution or of overlap is going to be where these two markers are sitting on top of each other. So, where is our area of overlap? There is no area of overlap. Can I pick a number? Any number here. We've got it broken up into three points. What happens if I try x is equal to negative 5? Does x is equal to negative 5 work here as a part of the solution? Yeah. But does it work here? Is negative 5 greater than a negative 1? No. So, negative 5 doesn't work. What about if I try 0 over here? What if we say that x is equal to 0? Is 0 greater than a negative 1? Yeah, it is. But is 0 less than a negative 4? No. So 0 doesn't work. Negative 5 doesn't work. Back here, what about negative 2? What if we said x was equal to a negative 2? So we've picked a test point from all three areas here. Is negative 2 less than a negative 4? Nope. Is negative 2 greater than a negative 1? Nope. So there is no area of solution here if this is a conjunction, if we have to meet both of them. So your solution here would be simply to say no solution. If we are talking about a conjunction or an area of overlap or an area of intersection, there is no place where the two graphs are lying on top of one another. So that's the difference between conjunction and disjunction. Okay? Now let's go ahead and look at example number 3 on our book. And we have 3x plus 4 is less than or equal to 16. 3x plus 4 less than or equal to 16, or negative 5x is greater than 20. Negative 5x is greater than 20. So disjunction, it's or. So we're going to have the union of the two sets, the biggest possible collection of answers here will be our solution. We're going to graph both of these inequalities on top of the number line. So, how in the world are we going to graph 3x plus 4 is less than or equal to 16? Can we graph it yet? No. Why not? What do we have to do? You have to simplify this inequality. So is it time for me to draw this number line on here? No. I'm hoping that had you been in class with me, you would have said, no, we can't draw the number line yet because we don't know how to graph our solution. So first we're going to simplify our blue inequality just as if it were an equation. You subtract a 4 from both sides of the equation and you have 3x is less than or equal to 12. You're going to divide both sides of this inequality by 3 and you have x is less than or equal to 4, or now we're going to go ahead and simplify our second inequality. And what are we going to do? We're going to divide both sides of this inequality by a -5. Now, inequality, not equation. What happens when you multiply or divide by a negative number? When you multiply or divide by a negative number, the direction of that inequality has to change. So we now have x is less than a -5. Let me make sure. Yeah, x is less than a -5. X is less than or equal to 4. Now we have our two expressions, two inequalities that we can graph on the same number line. And let's see what we have. So I'm going to say that we have 0, 4, this is my rough sketch here, and -4 and -5. So let's go ahead and graph this. I have that x is less than a -5. I have an open circle, and I include everything to the left of -5 on the number line. And then I also have that x is less than or equal to a +4. I have a solid circle because 4 is a part of the solution. And I have a very squeaky marker today. Now I have graphed both inequalities on the same number line. Now I have to evaluate it. I have to remember that I'm looking for or. Or is union. Or means as long as your solution fulfills one of these conditions, one of these inequalities, it's a part of the solution. We're not looking for intersection where you only have overlap. We're looking for the largest possible. It's going to be x less than or equal to 4 is our solution, because every number, including +4 and smaller, all of these fulfill at least one of our inequalities. So our solution to this disjunction is x is less than or equal to 4. Now we have another one. This is example number 4 on page 198. Two inequalities again. We have 3x minus 6 less than or equal to 12, or 5x greater than a -25. Five x is greater than a -25. So what do we have going on here? We're going to have the union of two sets, but in order to be able to graph these inequalities, we're going to have to simplify them. We're going to add 6 to both sides of the equation. 3x is less than or equal to 18. We're going to divide both sides of this equation by 3. And we have x is less than, less than or equal to 6. Now, let's see what our second inequality results in when we simplify it by dividing both sides of that inequality by a positive 5. The directions of these inequalities here did not change because we didn't multiply or divide by a negative number. The fact that we have a negative solution here has nothing to do with the direction of the inequality symbol. Now what do we have to do? We're going to graph both of these inequalities above the same number line. And I have 0, 5, negative 5, and I'm also going to put 6 in here. We graph our first inequality. Let me make sure that I have less than or equal to 6, greater than 5. First inequality, x is less than or equal to 6, which means that 6 is a part of the solution. X is less than or equal to 6. X is greater than a negative 5. This is how we graph both of these inequalities above the number line. Now, do we have a disjunction or a conjunction? We have a disjunction, which means that we're not looking for the area where we're overlapping. We're looking for a combination or a union of all of the areas that are shaded. So what do we have actually going on? We've got that area of overlap in the middle, but we have everything in a positive direction towards infinity. We have everything in a negative direction, forever and ever. So what is our solution then to this inequality? Our solution would be all real numbers, everything. See, I can't write all fast enough before my hand wants to write real. So we have all real numbers. That would be our solution, because our solution is not only the area of overlap, only this little piece right here would be the conjunction of those two, where you have the intersection of them, but when you add everything else in, as long as one condition is fulfilled, as long as either x is greater than a negative 5 or x is less than or equal to 6, that gives us this whole entire set of all real numbers. It includes every number as a part of your solution. And that's the end of that's the end of our examples. On page 199 it says this is how you solve disjunctions. It says solve each statement of the disjunction separately, which is exactly what we did. Then it says graph both solutions above the number line, which is exactly what we did. It says the solution to the disjunction is the union of the two graphs, which is exactly what I've been illustrating to you for every single problem that we've done so far. I think these are very straightforward. Make sure that you remember you have to simplify your inequalities first. You have to graph both of those inequalities above the same number line, and then you have to show your solution as being the as being the union of both of these inequalities. So work on these, send me a text if you're having difficulties, otherwise ask me questions on Friday, and I'll see you next time.